Engineering, brought to you today by VMH International, hosted by Daniel Snyder. Also presenting is Tim Banks and Heather Hellman with VMH International. Thank you for your patience. We'll get started now. I'd like to introduce today's host, Daniel Snyder. He comes with over 8 years of experience working in sales capacity. Dan has focused the past several years of his career exclusively on helping organizations create and implement product lifecycle management strategies. Working within the Automotive Aerospace Department of Defense, Dan has been able to obtain an intimate understanding of each of the industry's unique goals and challenges. As a trusted advisor, Dan works with his clients to deliver an industry-specific roadmap to achieve their goals, which may include shortened cycle times, decreased development costs, or increased profitability. Now I'd like to welcome and turn it over to Daniel Snyder. It appears we may be having a moment of technical difficulty. Just give us a moment while Dan joins the call. Thank you. Well, we'll go ahead and continue. Today's agenda, our objective is to assist automotive manufacturers and suppliers to drive innovation while increasing the quality of parts and assemblies while increasing margins. We'll give you an introduction of who is VMH, obviously our host, Daniel Snyder, Part 1 recap, webinar, Essentials for Excellence Part 2, how Siemen software can help. We'll have a questions and answers section towards the end, and then we'll review over VMH's key differentiators. And now we'll start. Tim Banks, if you'd like to take control.
Thanks, Heather. And we can come back to the VMH company overview when Dan gets back on the line. Sorry for those technical difficulties.
Hey, guys, can you hear me?
Oh, Dan, you there?
Yeah, sorry, I don't know what happened with my phone. I apologize to everybody out there. I was having some technical difficulties, but I switched over to the computer audio, and it looks like that's working for us.
All right, we are at the company overview.
All right.
Go right ahead.
Sure. Well, as you can see on the slide here, we at VMH partner with our clients to empower organizations and their employees to achieve their core business initiatives. We do this by enabling their team to better utilize the tools they already have, assisting them to evaluate and implement additional tools, and ensuring high user adoption. We are able to help organizations in a variety of facets, whether it be through Siemen software or other complementary products that we offer, such as Volumil, Vericut, Cortona, or Keyshot. If you'd like to learn more about any of these additional products, reach out to myself. I'll be more than happy to get you additional information. We also recognize that just because a company may have the best software does not mean that they're utilizing it to its full capability. VMH is equipped with many Siemen certified instructors who are prepared to help companies like yours to increase your product development efficiency through a variety of training and mentoring options. VMH also has its own first line of support for all of your technical software questions. As a VMH customer, you have access to local individuals who can answer the questions you have and act as a liaison between yourself and Siemens GTech if it is something that we need to involve them on. At this point, Tim, I'll hand it back over to yourself as we walk through the presentation, and I'll look forward to speaking to everybody at the conclusion of the call.
All right, thank you, Dan. And again, my name is Tim Banks, and on behalf of Siemens PLM and VMH International, I'd like to thank you all for taking the time out of your busy schedule to attend today's webinar. And we're just going to continue off where we left off in the first part of the series. Last webinar, which you can find on our website, there will be a link to that in our YouTube page, which you can rewatch that. We record all the webinars to show online. Last week, we talked about the seamless flow of information from concept all the way to how the design reduces engineering time by using NX, as well as how if you do analysis earlier on in the design process, you get fewer prototypes, and then with that, you save money and time. And one of the key differentiators for NX is that it provides value across a wide spectrum of domains within your company. We have looked at design and simulation, so now we're going to take a look at manufacturing. In automotive, a wide range of components are made using tooling, and that tooling has to be designed and manufactured. This tooling is often on the critical path to vehicle production, and this tooling is a high-cost element, and the end customers have a higher expectation of quality, so every year they want something better and something higher quality, which of course we all strive to achieve and deliver to our customers. And this chart shows an extended process chain from product design to all the way to production. And in this case, it could be that the production of tooling such as a mold or die tooling that will be used in the high volume production of vehicle parts. And we take component designs from product engineering and manufacturing engineering. We create a plan to make those parts, and then this plan is executed on the shop floor. On the shop floor, the success of the overall process is assessed. We ask questions like, are we making the parts or the tools on time? Are they meeting the correct quality specifications? And are we making good use of the proven processes and resources and so on? But success on the shop floor is largely the result of what happens in manufacturing engineering, where we actually build the plan and the parts and the ideas behind it. The better the plan, the better and faster the execution on the shop floor will be. On the shop floor, part manufacturers face the typical challenges of faster, better, and so on. The engineering department has its challenges as well as they plan the steps that will produce the part and put together the work packages for the shop floor. Their challenges are in general the planning and programming productivity. They need to create the manufacturing design, sorry about that, skipping ahead of me. They need to create the manufacturing plan, design tooling, create programs to drive machine tools and inspection machines, and do this accurately and quickly. If they make mistakes here, then the cost to fix those errors escalates enormously if it's not discovered until it is seen on the shop floor. So again, we just try to find the errors and before they go on the shop floor to kind of reduce time on the shop floor and get out parts quicker and have them be more accurate. And we need to create a good plan quickly and get it right the first time. And how does NX help with that? NX provides a single system that uses and reuses the same data across multiple functions. So with this, you can go from CAD to CAM to CMM, even some CAE analysis, all in NX with just a simple click of a button. And this means that the users are not having to create new part models from scratch as they take data into their function, say an inspecting program, or into tool or fixture design, or into another CAM program. They can just use the same 3D part model across all those different platforms. When changes happen, the updates can be driven throughout the different processes easily, quickly, and accurately. And this reduces the need to create 3D models in different systems or to make translations such as from STEP to NX, JT, etc. And these data errors can appear or model intelligence is lost. Having it all be inside NX, they're smart models the entire way there, and you see all the different features on the part. And with that, the model has all similar capabilities in it as well. And the models that come from product design nearly always need adjusting for use in different manufacturing processes, such as tool design, casting design, or CAM. In NX, users have access to powerful and flexible CAD functions, such as those provided by synchronous technology. We refer to this as part model preparation, and it's a key area of activity in manufacturing engineering. Edits like closing holes and gaps, offsetting faces, and resizing part features are just some of the capabilities that NX provides. This includes working on third-party CAD models, so importing anything you would like. In addition, NX offers a set of specialized CAD functions that enables the NC programmer to quickly analyze the part before creating the NC operations. And let's take a look at a quick demo.
In this example, we just take a quick look at how a manufacturing engineer can use synchronous technology to modify or edit a part. It could be working with a casting model, adding extra material to represent the casting, or just maybe representing a design change on an existing part, ready for programming. In this case, we're adding extra material here, dragging this complicated face or faces out, yet maintaining the integrity of the model, ready for machining or inspection programming. Here we're going to change a draft angle on this face here, again, maybe in preparation for casting, or maybe even for molding. A typical type of change or edit that a manufacturing engineer will make in preparation for programming or tooling design. In this example, we're looking at the same part again. We're going to add NC programs to a section of this part. This could be a casting model, for example, where certain surfaces have to be machined from the casting. The NC programmer inside NX CAM is going to select those surfaces to be machined, set up the machining process for those surfaces, and then use the repaint function just to validate or check the program that he's prepared. All inside NX.
I know that one may have been a little difficult to hear, but behind it all was that inside the CAM functionality, you can make a quick change, a quick edit to the model, where in other softwares, if it's a CAM software, all you can do is manufacturing capabilities. With NX, you can make a quick design change and continue on with your manufacturing. And now we're going to move on to tooling design in NX. Many automotive components are made in high volumes using tooling. And of course, we all know tooling means either injection molds or progressive or stamping dies, for example. Injection molds are used to make plastic parts, anything from large plastic fenders to electric switches, gears, or hundreds of other parts in a vehicle. Progressive stamping dies are used to create small metal parts, clips, brackets, and so on. Again, there could be hundreds of these in a typical vehicle. Stamping dies are much bigger dies that are used to stamp out vehicle body panels. These are specific to each vehicle and are a key part of the overall vehicle design and production. The dies are used in a sequence, and this sequential stamping process is addressed within the NX stamping die design solution. NX can address each of these types of tooling with highly automated, process-driven applications, all in NX, with one consistent model-based solution. The tooling or partly finished cast components need to be machined. The tooling components for mold and die parts require specialized hard milling capabilities, including high-speed roughing and finishing. Finishing passes especially must produce smooth, fine finishes for the best quality molded and stamped parts. NX CAM provides high-speed machining functions that deliver all of this while remaining associative to original geometry for fast updates. Preparing programs to drive the machining of castings, as well as the plates and blocks of tooling systems, can be done quickly and accurately with automation tools like feature-based machining. Some of the less obvious advantages of NX CAM is that the user has full access to the NX assembly functions. These tools are really useful for setting up arrangements of parts, fixtures, work holding items, and so on. The manufacturing engineer can do all this in the context of a complete 3D assembly model of the target machine tool. Most CAM systems don't provide this assembly function, and if they do, it's provided by using a different CAD package, and it is not an assembly, it's all one model. So again, we run into either translation issues or you cannot see how it is built. So the big idea behind NX CAM is that it provides a complete range of NC programming capability, including the machine tool simulation, so you can check your program, and it's all in one system from one vendor. And now we're going to jump over to see a video of Minco, a Siemens customer, and how they use NX on their.
Minco Tool & Mold's primary business is building plastic injection molds. We've been in business for over 50 years. Our competition isn't the company down the street. Our competition is the world marketplace. We were an early entrant into CAD/CAM, where we found a niche in the marketplace, whether it be just general machining or it be in the mold making part of our business. It is complex shapes.
We always strive ourselves in the quality of the tool that we take to press. We use NX NX gives us the tools to engineer our designs up front, whether it be a product design or a tool design. We want to make sure that we go through all aspects of the part and the tool early on in the process. By doing that, we know that when we start cutting chips that we're actually cutting what we want. We're not duplicating efforts. So it's important for us to maintain that accuracy through the entire process, and that's what NX gives us.
We get a supply file from a customer, and we'll take it in here and we'll redraft it and make it toolable. Basically, I will wrap steel around that part and make a mold base that will produce the plastic part.
NX is a strong modeler where we can bring in data from multiple sources. The ability to manipulate complex geometry is easier to do inside of NX because its ability to deal with explicit models, hybrid models, or fully featured models. We're not limited by the software in order to develop our product.
That is a Mold Wizard component. We drop that in, it automatically knew to hook into the ejector plates down here. All we did was put the part area on it by wavelinking in the part geometry into the lifter file and then trimming it off. And if we ever update that part, that lifter will update automatically.
We allow that master model then to propagate through the tool design into programming, where tool design will go in, update their model. Programming then will go in and update their data, their tool paths over top of the existing tool data. That's going to ensure that we keep accuracy through the entire assembly, knowing that the finished product we get out of the mold will in fact be
we program 100% of the model using the CAM software from NX, and then we do all our trode modeling, everything through NX, so the finished product. The master model is very important because everybody's on the same part at the same time using the same model. Everybody's looking at the same thing all the time. Everybody knows how to dimension, verify stuff. You don't have to teach 3 or 4 different softwares. So if it's everybody synchronized on the same software, everybody can help each other. You got to save time, you got to save money. So we implement the high-speed machining whenever possible, small cuts, light cuts at fast feed rates. And yes, NX has several options that that you can adjust your paths accordingly. There's options in NX that will actually turn the corners, which actually creates a much nicer and smoother path. It doesn't have the jerkiness of the machine.
It's faster, it's better quality. Now you just set it up and away you go. Sometimes you may have 12, 14 inches, and now we can cut that in half, which means better rigidity, better part finish, better tool life. Sometimes I'll run 20, 24 hours for a finished product with NX. We design in NX, we program in NX. So what you see is what you got. I mean, it's that accurate, it's that good. And without it, we wouldn't be in business. I mean, it's pure and simple. I mean, if you're not cutting fast, you're not making money. If you really want to cut a true part form and cut it accurate, you better have it all today, because the pricing isn't there anymore. It's a world market. It's serious business.
NX is an important product to us because it is an integrated product, and that's what we're about. We don't just design the part, we manufacture the part. So it's important to us to take it all the way through in the same software.
If we maintain accuracy both from product design, tool design, programming, through the building of the tool, we're going to ensure that we maintain a level of accuracy that gives us a high-quality part.
And there, it's always good to hear from a customer and see what they have to say about NX and the software. Some key points they all made were their increased productivity and the reduction of errors in using NX, as well as when they train either their programmers or designers or machinists, they train them all in one system, whether they're learning CAD, CAM, or CAE, they're all using NX, and so they all have that similar knowledge of the toolbars, the functionality behind NX, and how to use it. And now we're going to move on to the last example area. NX offers a programming application that helps you create inspection programs for coordinate measuring machines, otherwise known as CMM. Again, we use the same NX model technology, and the inspection programming does not need to create a new independent model in a different software solution. It's all based in NX, either a part or assembly model. The NX CMM inspection programming enables you to quickly generate collision-free inspection programs. You can reduce nonconformance and ensure accuracy to design requirements by programming directly on the NX CAD model. If the part designer has added PMI information on the CAD model, and added PMI, that's part manufacturing information, the inspection programmer can use this information to automatically generate inspection programs. This is a very fast way to do this, and it reduces the likelihood of errors in programming. You can further automate the programming process by applying your standard inspection path methods, tools, and project templates. This PMI is very important, and it's a way that everyone is going away from drawings, and that is a point of the drafting, is to see those annotations. A lot of companies, especially in the aerospace and now automotive industries, are moving to PMI, and so all those annotations are on the 3D model, and those, like NX, can be used downstream, where if you put them in on the CAD level, that's all smart data that can be used either in CAM or this CMM inspection programming downstream. NX provides the ability to capture and leverage the enterprise's collective knowledge into repeatable processes. NX also provides the capabilities to quickly find and reuse the existing parts and systems. The ability to embed engineering rules into the process allows for intelligent part and feature reuse. In addition, NX's knowledge-based validation tools allow for the automation of standards checking. By reusing all your existing data, designs, and processes, not only can products be designed and manufactured faster, but better product results. So NX you can take your part, edit it around a bit, or build a library, and you can take parts together, which we will show in a later demonstration, to get your design quicker and to the machine shop quicker. NX provides overall cost reduction through increased levels of reuse and adaptation. NX users can take advantage of integration with Teamcenter's classification capabilities from within NX applications. These users can navigate in real time through a class hierarchy, view class attributes, and issue queries to search for class members based on ranges of class attribute values. This includes ready-to-use standard part libraries consisting of over 100,000 standard parts, which include screws, washers, nuts, bearings, pins, anything you can think of, anything that would be just a basic part that you would get sick of modeling over and over again. These are all inside that library. Additionally, Geola Search is a 3D search engine which will rapidly track down parts similar to a given example based on its geometry. So if you put in a screw, it can realize what it is and pull out parts similar to that, and then you can search and view which are the correct sizes you need. Product and process knowledge is the most valuable intellectual asset of automotive manufacturing companies today. This knowledge is frequently locked in the minds of a select few, limiting its use and value to the enterprise. Your engineering processes have been developed and fine-tuned over many years. Your infrastructure and product teams are built around these processes. NX's knowledge-driven solutions provides you with the ability to capture existing design, analysis, and manufacturing processes digitally to automate and optimize them, and of course to reuse them, making you even more productive. With NX product templates, you can automate much more than the design modeling. To automate and standardize engineering processes, you can incorporate product and manufacturing information, drawings, motion analysis, structural simulation, and validation checking into the templates. One example of this is Product Template Studio. Product Template Studio, or PTS, uses a simple drag-and-drop environment to help overcome some of the traditional problems faced when reusing knowledge and data. PTS provides rapid generation of reusable design templates and allows any design to be adapted for reuse. With PTS, engineers can publish the key design variables for a component or assembly, and these become the key-driven parameters that control the product. Product Template Studio brings codeless customization to the designer, enabling design for reuse strategies to be easily implemented and delivering a solution that extends the benefits of a parametric modeling in an enterprise. These templates can then be stored and accessed from the reuse library directly from within NX. PTS users report 80% gains in productivity and over 90% reduction in template authoring time. And now we are going to take a quick look at an example of PTS and how reuse of parts or standards can help overcome some of the traditional problems faced when reusing knowledge and data.
Now we will review two requirements for the sunroof opening. First, the open and close and tilt times must meet minimum specs to satisfy customer expectations. The second requirement states that the sunroof opening size needs to increase in response to customer preferences. Going into HD 3D requirements validation, we can see that the current design does not meet the sunroof opening size requirement. Specifically, the rails must be at least 403 millimeters long, and they are only 378 millimeters long at this point. Using synchronous technology, specifically the move face command, we move the ends of the rails out to make them long enough to meet the requirements. Now we need to bring in the roof bow. Using Product Template Studio, we reuse an existing roof bow design. Now we examine the roof crush requirement that the roof bow must meet. The requirement states that the bow must be able to withstand 3 times the vehicle's weight. Using assembly arrangements, we can select 3 different states of the sunroof: open, closed, and vent open. We select fully open. Looking closer, we can see that we have several areas where the rails and associated sunroof parts interfere with the roof bow. To correct this, we begin changing the roof bow by using the synchronous command xform to modify the surfaces. Notice that you can change only one part of the surface, and that the symmetric surface on the other side changes at the same time. Now we will edit our template part by selecting Edit Reusable Component. We will make some changes to the parametric history-based dimensions that drive it. Now we will use Emboss to create a pocket to move the mounting surface down to the correct location. Once it's created, we see that it interferes with an existing part. So we once again use Synchronous Technologies' Move Face command to move that face out to correct this problem. After a few prep steps, we run a predefined CAE wizard to analyze the strength of the roof bow after the changes we've made. The wizard applies a force equal to 3 times the vehicle weight to the center of the roof bow. The analysis shows that the maximum deflection is 3.24 millimeters, which is acceptable in this test.
And with that, again, you can see all inside NX. You can go from CAD, make a quick change using synchronous technology, and then even if it isn't an in-depth CAE analysis, you can have your designer at least run a quick nodal analysis to see just a quick, okay, what needs to be changed on this for quick iterations instead of creating prototypes or sending it over to a CAE guy over and over again. You can run quick analysis and see what small changes you need to make inside NX, all in the same program. And for the rest of this presentation, we're going to look at how continuous collaboration throughout the development process can help in reducing product development time and improving quality. Your designers require 100% confidence in their ability to find and access the latest info, work on latest versions, and synchronize data between different company sites. The Team Center integration for NX provides seamless management, control, and security of your data. This enables users to rapidly search for designs and manage data revisions, product configurations, and changes to these configurations. Team Center also provides NX the support for multi-CAD collaboration. Team Center automatically manages both native and neutral CAD representations. This eliminates unnecessary delays caused by constant data translations. Team Center also provides key process applications like engineering change management, requirements management, and more. Key to the process is a suite of HD 3D tools. High Definition 3D merges your product geometry with key PLM information accessed through Team Center and enables you to visually comprehend PLM data with interactive navigation and to drill down the details as needed. This gives engineers the ability to find and fix problems fast. Information is not limited to CAD data. HD 3D can access information directly from Team Center. For example, product costing or what the supplier is manufacturing the part. HD 3D is an intuitive way to present product and process information to aid decision making. HD 3D visually delivers the information you need to understand, collaborate, and make decisions in distributed product development teams. HD 3D provides visual reporting of Team Center managed data directly in the 3D product development environment where it can be immediately applied in critical decision making. This means that a designer or engineer has immediate access to information inside his or her NX session. HD 3D enhances validation tools and reporting with a new visual user interface for analyzing and reporting issues. In this next example and demonstration, we will use HD 3D to do a body layout study inside NX.
Here are a couple of examples of NX design and validation capabilities. The first is NX Checkmate. We can use the Checkmate tool Weld Advisor to check the 4 welds at the top of the end of the B-pillar. The analysis shows that the weld spots do not meet the requirement for minimum edge clearance. This type of check helps you catch issues early instead of later when fixing them is more expensive and time-consuming. In this next example, we'll use HD 3D to do a body layout study. We'll start off by bringing up the appropriate template to modify occupant position. Since this car is to be sold in all markets, both left and right-hand drive need to be evaluated. For this concept, the driver is shifted forward and up. Notice that the pedals, seats, and everything else move with the driver. The roof system option, sunroof, is selected because it offers the least clearance and therefore is a worst-case scenario for evaluating clearance. Using visual reporting, we view the sunroof study that contains the minimum clearances. We run a test using Checkmate and see the minimum clearance for the occupant's head is not sufficient. After examining the failed area, we open the effective parts and find the actual distance is 33 millimeters. Taking a look at the requirement, we see that it needs to be 45 millimeters. Going back to the template we started with, we lower the occupant by 17 millimeters, execute Checkmate again, and everything passes. Finally, we turn on more layers to see the body of the car.
And some key points to remember through all this were that with NX, you can use everything from CAD, CAM, CAE, and the CMM inspection. That's all built into NX. So whether it be your designer or manufacturing engineer, they all use the same platform, so they all can sort of speak the same language and see all the other parts. So instead of bringing in separate CAD data, they can all see native parts inside NX and use all of its functionality, whereas bringing in a part from another CAM system, you would lose functionality and data. As well as this with NX, and you could see the customer and what they said, it's all about time is money. The quicker you can get the part out and the more accurate the part is, the more money everyone will be making. And with that, we are going to throw it up to questions and answers. If you have a question, you can go ahead and type it in the question pane. And I'll unmute you, Dave. Unmuted. And I do have one question on, it looks like, on PTS. Just they want a little more information on that. So Product Template Studio, it's a separate add-on. Well, it's all built into NX, but it's a separate item from just a normal CAD package. And you can discuss that with Dan if you would like. But behind PTS, it's based off of a lot of commands inside NX. So just for example, simple example, you have a 24-inch diameter tire, and then if you want to change that to like a 26-inch, you could add those options of like a drop-down option where you can go from 24 to 26. And with that, it would also change the size of the rim, and it would change the location of everything else. And it's all built in using if, else if commands inside NX or Microsoft Excel. And then with those smart commands, you can create sort of a Visual Basic. You create your own NX dialog boxes. And then you can create, 2, 4, 6, and between all the smart commands and those dialog boxes, you can create your own templates that can be reused over and over again. So you can save time instead of either assembling them all differently every time you want to assemble something. With just a few clicks of the button of your mouse, it'll be assembled automatically with a lot of time up front you'll need to create all the smart functionality and the assemblies the first time. But once you do that, all your designers, they just click, okay, I want 4 of these, 2 of those, and I want it to be 3 by 5. It takes all that data and knowledge and puts it together and creates the part for you based on your template.
Unmuted.
All right. Hey, Tim, we'll give it a quick 5 count for any additional questions. I don't see anything in the queue right now. Anything on your end?
I see one asking about Team Center implementation. I think you can handle that one.
Sure. So we spent a lot of time today focused around NX and the product design and simulation side of the software. Teamcenter is a large product inside of the PLM suite at Siemen Software, and it's absolutely one that VMH supports. We work with many different organizations here, both locally in the state of Michigan and across the country, helping them from ground-up implementations all the way through tweaking additional installs that are already out there. We can assist by coming in and actually help derive what the requirements for a PLM tool or PDM tool may be. If anybody has any questions as it pertains to an initiative to go out and look for a PDM tool like with Teamcenter, feel free to reach out to me. I'd be more than happy to help out.
And all this is my contact information, so at VMH, I do first-line support for us all, for all our customers. If they have any issues, they can either email or call me or our 1-800 number. And with that, I help out with any issues they may have, whether it be having trouble installing or if they found a bug inside NX, I can try to find a workaround as well as report that to GTech to get it fixed in the next release. Or just, simple questions on how do I do this, or, I want to change the font on this, or how do I, just any questions you may have, our first line support team is here to help you out.
I'm muted.
Okay, thanks, Tim. And we'll just jump into a little bit more about who VMH is and how we set ourselves apart. As you can see, this slide goes a bit more in depth about who VMH is and our company's background. VMH has been a Siemens PLM software provider for many years, and is consistently one of the top Siemens partners globally. We understand that companies are continuing to expand and no longer work out of a single facility, and for that reason, we currently have 10 satellite offices. This allows us to have a truly global presence, especially when we get into some of the large implementations on both the NX CAD, CAM, CAE piece, as well as Teamcenter, if we have the footprint necessary to help with an implementation regardless of location. As we move forward, the next slide will demonstrate some of the key differentiators VMH has versus other Siemens resellers. Like many VARs, we have the ability to sell Siemens software. However, we at VMH take it a few steps further to truly add more value to the client experience. VMH has been working with both Amazon and Microsoft to offer cloud-based Teamcenter implementations. This allows organizations to be more agile, working within their Teamcenter test environment. Gone are the days of duplicate IT infrastructure just to see how a few changes here and there is going to affect your production environment. As you see in the bottom left-hand corner here, we also have a group of summer interns, which we refer to as the Dream Team. These are here to help out with our clients when the workload starts to pile up, or there's just that special project that requires some additional R&D. Our Dream Team interns are pulled from the nation's top collegiate engineering program and are here to help when the time comes. So that's all we have for today in part 2 of the Essentials for Excellence in Automotive Design and Engineering webinar. And hopefully you came away with a few ideas on how to improve the way in which you design products. As stated earlier, the intent of today's webinar was to assist our clients to utilize reuse for cost reduction, as well as enhancing collaboration to deliver more innovative products. If there are no more questions, on behalf of VMH, I'd like to thank everyone again for taking time out of your schedules to spend with myself and the rest of the VMH team. We look forward to working with all of you in the future, and I hope you have a great afternoon.